All right. 6.1, roots and radical expressions. Now first, before we get into roots, we have to actually know vocab. So one thing here, when there's a little number outside front, that will tell us the index. You might hear me say, my index here is this number. It's the same type of thing, like if you have 5 squared, kind of like a power, that's how you're thinking of it. Your index will give you the degree of the root. This is your radical sign. It's so radical, like so radical. And depending on what your index is how you know how to solve it. And I don't even know how to say this word, so I'm not going to try. But that's that. Whatever you are taking the root of is that word. Begin finding real roots. I'm not going to go over all this spiel. I'm just going to go over when we have odd cube would be odd, or fourth would be even root. So think of it this way. If I had 2 and I cubed that, that's 2 times 2 times 2, that's going to give me 8. If I had negative 2 and cubed that, that would give me negative 8. Because when you do 2 numbers, negatives, it's going to give you a positive. If you do 3, it's going to be whatever the original was. So when you have an odd root, you're always going to have only one answer. So in this case, if I had what's the cubic root of 8, it would just be 2. What's the cubic root of negative 8? It will be negative 2. Fourth root is a little different. So I have the fourth root. If I did 2 to the fourth, that would be equal to 16. 2 times 2 times 2 times 2. Or if I had negative 2 to the fourth, negative 2 times negative 2 times negative 2 times negative 2, that's 16. So these give me the exact same answer. So whenever you have an even root, you're going to have 2 answers that it could be when you're solving. You could have 2 answers. An odd, cube is odd, root, you will only have 1 answer. Depending on whatever it is how you know if it's going to be odd or even to begin with. So with knowing the difference between odd and even roots, this is where we have to be careful when we're simplifying a problem. So I'm going to look at this. I'm going to simplify. This kind of is confusing. I'll go into that once I have an actual problem, an example. So I go into these 3 problems. I want to simplify the radical. So the first thing I do is rewrite any numbers that I might have, like 16 in prime factorization. Prime factorization means what are the prime numbers and how many of each are there for me to simplify. So 16 would be 2 to the 4th. I still have x to the 8th. Now a square root means that you're looking for pairs. A square root, you're looking for groups of 2. So there's 2 ways that you could do this. You could write them out and circle cross out. That's how you do it back in geometry or in algebra. But another way you could do this is if I'm looking for 2's, I'm going to divide both of these exponents by 2. So I could rewrite this as 2 squared to the 2nd, and this would be x to the 4th to the 2nd. Because once you take a square root of something squared, example, if I had 7 squared and I took the square root of it, these 2, because my index here, if there's no number, it's always 2. If there's no index, it's always 2. And since this index is the same as this exponent, then those 2 will cancel each other out, leaving me with whatever underneath. So it's the same thing here. This is a 2 here. If there's no number, it's a 2. So once I rewrite this, this square root cancels out with this squared. The square root cancels out with the squared. So this answer is 2 squared x to the 4th. And you can write 2 squared as 4 if you so wish to. And so getting back to that absolute value thing, it's kind of the same thing from the last slide. When you have an even exponent, your number's always going to be positive. So looking right away at my beginning, this was an even exponent, so this number should always be positive. Even if this was a negative 1 or a positive 1, my answer will end up being a positive 1. So you want to make sure that this is represented in my final answer. So since this is also an even exponent, I don't have to do anything with that, because this, again, no matter what this x is, it's going to give me a positive answer. So this is my final answer right here. So next one, I'm going to be looking at these, and I'm looking for groups of 3. So this is the same thing. If I wrote my cubic root, this is the cubic root, and I'm going to divide each of these exponents by 3. So this would be, in parentheses, a squared to the third. So I'm dividing it by 3. So 6 divided by 3 is 2. So that's what's left inside. My b is b to the third, because I want to write them as cubic. Because now since my index matches these exponents, they will cancel each other out. Or again, you could look at groups of 3. If you want to do this the long way, you could rewrite this as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you could look for groups of 3, because that's the same thing. Since this is the cubic root, anytime you have a group of 3 underneath, it represents one whole. So this would be 1. This is 2. This would be 1, 2, 3. It's the same thing here. These roots cancel each other out, leaving me with just a squared b to the third. Now again, when you look back at your original, the a, because this was a positive exponent, right back at their original, because this is a positive exponent right here, this should also be a positive exponent. If not, you would have to do an absolute value. Because with a positive exponent, you're only going to get a positive answer. So this a should only be a positive answer no matter what. The b, however, the b can be negative. I started off with an odd exponent, so this could be positive, negative, so this answer could be positive or negative. And this last one, same type of thing. Now, I will tell you that these questions are a little bit easier because they all end up to be nice numbers, but I'm taking the fourth root now. So my fourth root, so I rewrite my x's. This would be x squared raised to the fourth, because I'm dividing by 4 to figure out how many groups of 4 do I have. This would be y to the third raised to the fourth. Again, this is where your properties of exponents. These should multiply to get 8. These should multiply to get 12. So now, this index, a fourth root, can cancel out these fourth exponentials. So my answer would have x squared y to the third. But I look back at my original problem. This x has an even exponent. That means no matter what number you put in for x, it should become a positive number. This x has an even exponent, so that's good. Because no matter what I put in for x, it should be an even number. When in doubt, try negative 1. If you put negative 1 to the 8th, it would be a positive 1. If you put negative 1 to the squared, that should be a positive 1. So that represents the same. 12. If I put negative 1 to the 12th power, that would give me a positive 1. If I put negative 1 to the third power, that would give me a negative 1. That should not be happening. So what you have to do is when you write your answer, you have x squared, because that one's okay, times you have to put the y cubed in an absolute value. So that even if I put a negative 1 in here, and it becomes a negative 1 cubed, once I take the absolute value of it, it becomes a positive 1. You should pause the video and try to do these 3 by yourself. So here are your 3 answers. The first one, I'd rewrite as 81 as 3 to the 4th. And then, again, you're looking for how many groups of 2 do you have. So you have 2 groups of 2 for your 3's. You have 2 groups of 2 for your x's. So 3 squared, x squared. Second one, my a started out as even and ended as even. That's okay. My b started as odd and ended in odd. That's okay. So once I found my groups of 3, it's a to the 4th and b to the 5th. My last one, looking for groups of 4. My x started as even and ended as odd, so that's why this absolute value has to be there. Because this should end as a positive number. Because when I started x to the 12th, if I put negative 1 to the 12th power, that should end up to be a positive number. So this number should end up being a positive number. There's your answers. So here are just some more practice problems. The first one is the square root of 25a to the 4th. So square root of 25 is 5, square root of a to the 4th. That's just dividing because my index here is 2. It's just like dividing your exponent by 2 because my index is 2, so this would be a squared. Started to even, ended even, so that one's good. Second one, I would be dividing by 4. So I have 3 groups for my P, and I have 1 group for my Q. Now this one, because both of them started as even and ended in odd, you have to put your absolute value here. Because I started with an even exponent, and I ended with an odd once I simplified. Started with the even, ended with an odd. So you want to make sure to put these in absolute value. Fourth one, you can pause the video and just try them yourself and then check them. Square root of 9 is 3. Square root of b squared would just be b. But again, once I write this b, this is the first power. So this started off as 2, but it ended as 1. So this would have to have an absolute value with it. So again, no index. It's always a 2. It's a square root. So you have to think, how many groups of 2 does a to the 8th have? It has 4. Started as an even, ended in even, so that one's good. And b is, there would be 9, but b, or 9, is odd, so you want to make sure to have that one in absolute value. Last one, the cubic root of 125. There's certain cubic roots that you should just know, like 8, 27, 64, 125. That's 2, 3, and 4. The cubic root of 125 is 5. But this goes back to the very first slide of real roots. Since this is odd, my answer should be a negative number, because whatever, if it's odd, it should match what you're taking the root of. In this case, this would be 20 or 5. The cubic root of negative 125 is negative 5. And then the cubic root of a cubed, those kind of cancel each other out, would just be a. I started with odd, I'm ending with odd, so that is my final answer, Lillian. And now I have 2 bonus questions. Oh my gosh, you're so lucky. Bonus questions, what? So, in this problem, 27, I would rewrite that as the cubic root of this is 3 cubed, x to the 5th. Now, all the problems that we had before, it was y to the 10th. They were nice and easy. They could divide it out. Now I don't. Well, these 2 can cancel. This cube root can cancel with this 3, so I'm for sure going to take out that 3. But now I have x to the 5th, I think, how many groups of 3 do I have in x to the 5th? So if I do this the long way, that 1, 2, 3, 4, 5, I have 1 group of 3. That means I can take out 1x from this root. I have 1 group of 3. If I did the same thing for my y's, there's my 10 y's, and if I want to look, here's 1 group of 3, here's 1 group of 3, here's 1 group of 3. So I have 3 groups of 3 for my y's. So this is all the variables that can come out. However, now I still have to write what I have left over. So when I'm writing my leftover stuff, that 3 goes there. This is still going to be the cubic root. This 3 canceled, that's where that came from. My x's, I took out 1 full x. Inside, that was 3 x's, so I'm left with 2 x's left inside. I had a 10, so that's going to give me 1 x left over, because you took out 3 groups of 3, so you took out 9, so 1 y. Now when you're doing this, I think you have to ask your teacher what they prefer, but when I look at this y was to the 10th, and now this is y cubed on the outside. I would want to make sure that this whole thing, this whole kit and caboodle, is underneath the absolute value. I'm not sure if your teacher's going to be picky, saying it just wants it around the certain variable that you have to make sure, but this whole thing should be in absolute value because of the y's, not because of the x's, because you started off with odd, so that's okay, and you ended with odd. So try to pause the video and try to do the next one by yourself. Your answer should be 2x cubed y squared, and then the 4th root of 2y squared. And the reason why is because 32 can be written as 2 to the 5th. So I'm looking for groups of 4. So me taking out 1, 2 here, that means I took out 1 group of 4 on the inside, leaving me with just 1, 2 inside. X to the 12th would be, I can have 3 groups. That's where the 3 comes from. There's 3 groups of x to the 4th inside. Y to the 10th. there's two groups, so that would be 8. So that's 8 on the inside. But I didn't have 8. I had a total of 10, so there was 2 left over. Now, one thing that I'm missing in my problem is this x started as an even exponent. That means all my answers, whatever I put in for x, should always be positive. Well, this is odd. So since that's odd, again, ask your teacher, make sure that you have absolute values around this problem because of that. However, if your teacher just wants it to be around just the variable, this is how it could work. Also, 2 times in absolute value x cubed, because it was the x variable that was causing us a nonsense, because the y's started even so it can end even. And then the fourth root, so a little 4 guy, and then 2y squared. That's another way that you could write the problem, just like that. That's all we have for 6.1. Hey, you have a great day. Keep smiling.